Well, there's a homework problem I wanted to assign on gear trains. I liked it a lot, but I didn't cover enough, I think, in class to be entirely helpful. So this is the helper video. I'm going to make it go kind of fast so you can pause and go backwards. I'm not going to write the things out because I just got done reading these. All right, so our goal here, if I can get the thing to focus, okay, is to make an 18-to-1 gearbox and that's reverted, by which we mean the shafts are in line with each other. I think I might have mentioned something about them rotating in the same direction. That's just sort of a distraction. They will rotate in the same direction because we're going to use just two stages. Can we use two stages? Well, here's one test of that. We could say 18, the square root of 18, so you could see, oh, well, it is possible to get this done in two stages because we're not going over the 10-to-1 limit. If I wanted to be cruel, I would make this thing larger than 10, which would mean that we would need to do the thing in multiple. And that might mean we might want to go in 4 stages instead of, the conclusion might be, well, you have to do it in 3 stages. Might be better with that design goal right there. But we made it simple enough. All right, so if we were going to just break this thing apart into increments, nice even increments, this works. There are techniques that we could use. If these came out to fractions that we had to do, small decimals, we could mess around with that. But that's supposed to say it works. I don't know if it worked. I don't know what even that is. It works. All right, there you go. All right, don't know what word. Words don't work very well. Okay, so that might be, okay, so we could say if we had, and we're numbering the gears for whatever reason, 2, 3, 4, and 5, right? We're skipping number 1. Who knows why? They just don't do it. So you know that the number of gear teeth of 2 is 6 times that of 3, and likewise that you would have 4 would be 3 times that of 5. And these are nice whole numbers. That's good for us. So for the shafts to align, the diameters, the sum of the diameters have to be equal to the to each on both sides. Why is that? Because the centers have to be the same distance apart. So if we decide that we're going to use the same pitch for both things, what ends up coming, instead of just the diameters the sum of the diameters have to be equal to each other, the sum of the number of teeth have to be equal to each other. So N2 plus N3 have to equal N4 and N5. I'm going to move these cameras around, move the camera around a little bit. And so what we could do is we could substitute these into each other, right? We could substitute 1 and 2 into this equation 3. And we could get it reduced now down to this. And bringing them together, we have this. Now, just a quick little trick, it'll be obvious afterwards. If we were to say make n equal to 7, and so n5 equal to 7, and n3 equal to 4, that would be true, right? That would solve the thing. But 4 teeth isn't enough teeth. Now there's 7. But we don't want to have interference. We know that there is sort of this lower limit for interference. And fortunately, one of the lower numbers is 16. So if we multiply that by 4 and that by 4, so this is 16 teeth, and that's 28 teeth. And there you go, 16 for the interference. We have this value, which is satisfied by 16 teeth for N3, 28 teeth for N5. All right, so that means that we would have 96 teeth for N2, which is large, but not crazy large. It'll work. And then for N4, we would have 84 teeth. So to summarize, here are our gearbox teeth, and we could also just double check the distances, but we're going to need the distance anyway. So I decided to pick 6 teeth per inch is my pitch. Maybe we were told what it should be. We might need to pick that pitch because of strength, by the way, because in the stress calculations, we do see pitch comes up in that. we could find that here's the diameters with that pitch, and here's the center to center distance, and it better be the same center to center distance with this. And it turns out that it is. Okay, so it works. So now it comes, so that is very similar to your homework problem. One might think that it's too similar to the homework problem. I don't know. I won't make that judgment. But the other part of the homework problem is to make this in SolidWorks. So here is a quick demo of that in case anyone were to think that's an unreasonably difficult thing. You will see here you can time me, and well, actually, I guess the seconds are going by, so it'll be time. One of the things I said to do was to make the shafts, or the shaft, I guess say shafts, 1 inch, and I think it'll work out in these, although that one gear does have, it is only 2.667 inches in diameter, so making this a 1 inch shaft, it's going to be, especially with the keyway put in there, it's going to be pretty large, but I'm going to stick with that here, okay? And if you're clever about it, or not even all that clever about it, you can have the same shaft be on all three. Well, you need 3 shafts, and so you can use them. I think I'm going to start out with this 12, make the shaft 12, and then we'll just see where it goes from there. See if that makes sense. This is the true design process here. So I'll save as and put it someplace. I think, okay, so I want to go up into my correct directory. Always good to keep a very organized directory. And I have a SolidWorks here. And I have this one right here. So this is I just did the problem myself. So I will go for the part and homework example. I'll write example in here, example, and I'll probably end up reusing that name. So I'm copying the name right there, so I don't have to write it out again. So there's the shaft. All right, so now we can go into and create an assembly, a new assembly. Not terribly difficult to do. I'm not going to use that part yet. I'm going to make my background white again, and I'm going to make my units into inches. And I think I'm going to go to my front plane, and I'm going to draw a line that is vertical and the length of my center to center distance, which we just said was 9.333333333. And you go, well, that's got a repeating threes. Is not going to be accurate, not precise. Well, that's actually one of the difficulties in real machine is trying to get the shaft distances to be exactly. There is a little bit of a tolerance that's inevitable. I'm going to go ahead and make axes as part of this. So, it's almost be better to turn these on just to see them and just to see what I'm doing a little bit better. So it didn't show. Oh, I guess I don't have it on the view. What is this? Oh, it's hide show planes. All right, there you go. So I'm hiding and showing my plane. I'm going to make axes in my assembly reference geometry axes, and I think I'm going to pick this plane, and nope, I need to pick. All right, 1 second. Let me think. I need to pick this plane and pick that point. Yes. So it's going to be the Pierce one, right? Point and face thing through. All right. So I'm going to need this again, and so I'm going to pick this thing again and pick that again. Okay. And I just had a little bloop thing. I don't know what the bloop thing meant. But anyway, I think I got my 2 axes. Yes, 1 and 2 right there. I can go ahead and hide all these planes. I don't need them anymore. I just want to point them out. All right. Okay, now I'll put in my components, and I'm going to put them in 3 times. All right, so shaft, shaft, and shaft. and boom. And I think the first one is probably going to be, it is, it's fixed, so I need to float it, right? So otherwise you won't be able to get it. And so I don't have to do this first, but I decided to do it first, so I'm going to do it anyway. I'm going to arrange these with my axes. So I'm putting them right in there. Did it make it concentric? It sure did. Okay. Here's another one. I'll use that same one there. Boom. And accept it. And then is this the guy that can move? Sure. I'll make him, and then I'll use the right there. Boom. Okay. So what I've done is I've got it ready. So here's the input shaft, let's say, output shaft, and here is the intermediate shaft right there. Could have done these afterwards, didn't matter. Go to the toolbox, and I'm going to go to ANSI inch and go to power transmission, go to gears, spur gear, and bring one over. All right. And we decided to make it 6 diametral pitch. And number of teeth, let's go for my first stage was 96. So let's go 96. And it appears that the nominal shaft diameter is already 1 inch. The face width, that doesn't look too bad. It doesn't look crazy dumb, so we'll just stick with that. These this is something that we would also select when doing a stress analysis. So we're going to accept it. So we know that that one's correct, and I'm lazy, so I'm just going to put 3 more in here, or in there, and then cancel out. All right, so they're all the same gear. I can come down to the second one here, right click it, and edit in the toolbox, and change the number. It could be anything we want. Let's make the 84 because it's the least distance we have to go down. All right, and then I'll go to the next one and edit the toolbox component and make it into, what's the next one? So it's going to be 28. Is that right? 28. Scroll there. 28. Boom. And then here's the little guy. And make him, it's going to be 16. All right. So the consequences of having an interference-free thing is to, or to make stages. It's just like, there, you're kind of a small guy. I don't know what I was saying there, but I was trying to say something. All right, so now I go back to my mates, and I'll just go in and mate that to that. I'm going to scoot him over there. And that's going to be mated to this guy, right? Because that's the way that we go. We go 96. I don't know if that, or what got in there. Let's see. Let's put him in there. Oh. Didn't grab a hold. There you go. Up to here. Boom. I'm going to shove him over a little bit. And then we're going to go, then we go 84 onto here. Slide him over a little bit. And then put that guy in there. All right, now we just have to do a little bit of cleanup. I'm going to make that face and that face coincident. And then I'm going to make this face and that face coincident. And then I'll make that face and that face coincident. We'll fix the gear teeth in a minute. And we'll make that face and that face coincident. And all the way over there. Make that face and that face coincident. And then I'll make that face and that face coincident. Boom, easy enough. Yay. And if we want to get the teeth to align, and it's just cosmetic, this is going to get in my way here, but I'm going to make that surface, and I got to turn this thing around and get over to this surface I can't see right there. I could do that in another technique, but like I could go like select other, like right here if I want to. get experience select other. Oh, there's too many things to get in there, and that's not a good chance for select other. But let's see, I can't quite see what I picked now. There, boom. All right, let me do it again. I'm going to pick this face, and I'm going to come around here and block it out for a second. And I guess I'm going to make it that face, and we'll make a tangent. There you go, boom. Not the easiest thing to do, but you definitely made it so that the gear teeth, I mean, it can't spin very far, but you did set it up at least so it looks correct. They're not cutting into each other. I did the same thing with that and rotate it just a little bit easier this time, and that, and make them tangent. Boom. There's, by the way, if you wanted to, there we could. So here we've got them set up, and we could just suppress that constraint. I mean that mate later on if we wanted to. If we wanted to just get it started in the right spot, and then you can also apply these. Not analysis, mechanical mates, and all you do is just you do the gears and you tell it what the diameter is or the pitch diameter is, and now it'll make the things rotate correctly together based on the gear ratio that they have, based on those diameters. That this mechanical mate. Anyway, there's other things that you could do, but if that's an interesting thing, you might want to care about. These are kind of far apart. So we might want to come back and go back to our others and say other piece and say, well, that was kind of foolish how big we made that. Let's just make it 6 inches because the 12 inches made them really too far apart, and we're just making it for demonstration. All right, so there you go. That makes it. That looks a little bit more useful. Now we're going to save this. And I think I'm going to be saved in the right spot. And did I thought I said, whatever. Okay, I thought I had copied and pasted. Apparently I didn't. ME470 homework 10 example. All right, so that's the example one. And we'll save it. All right, and now we're almost there. We're almost home free. What am I like? A little less than 10 minutes, a little more than 10 minutes. Okay, so we want to create a drawing out of this, and we'll go and make it B portrait. And we could do this right here if we want. Let's go ahead and do it. We'll create multiple views. We want the side and the front. Somehow there's a couple extras in here. I don't mean. Why do we have these extra guys? Why is there 3 things? I don't like it. I don't like it. Huh. Is that turned on or something? Why is it? Why am I seeing many of these things? I don't like it. I have too many things turned on. No, a trimetric. All right, those 2 things, maybe. All right, well, you can tell already that's going to be too small. Let me actually just hit this OK and see what happens. Oh, I see. He's making putting the shaft in there for some stupid reason. Yeah, I don't know quite. So we're going to get rid of that and drive view and forget you. Oh, wait, we don't want that one either. There. All right, so this happens every now and then when I go to put in a model. Insert model as into the drawing view from a model. It doesn't show up. Just the shaft does, and the assemblies won't show up. See, there's problem 1. I don't understand why this happens, but I gotta fix it. Okay, 1 second. I'll pause my video. Hopefully this video is still working. Still working onto this thing. I mean, it would suck if it didn't work. Pause. I think I have it figured out. I think it's because I'm working off of OneDrive, and sometimes the folder, whenever it doesn't refresh or something, you can see the file in the folder, but SolidWorks doesn't see it for whatever reason. But I think I got it to recognize now. Okay. So I have the, keeps wanting to do this shit. I don't know why. Okay, there you go. So this is the example. So there you go. All right. Now we got to make sure we have it in the correct scale. We can mess around with that later if we want to, but that doesn't look big enough. So we're going to go to use the custom scale, and we could double it. What would happen if we went like there? Oh, it's too big. It doesn't fit on there. We'll stick with this and see if we could go maybe 1 to 4 instead. It wouldn't make sense to do anything else. Yeah, it's still pretty small right here. So I'm thinking I'm going to go ahead and try my own in here. So you can type in here. I wouldn't make anything exotic, but 4 to 1, that's not too unreasonable. And we use up we use up more space on the page. That's an important thing to do. So I am going to cut the video short, and I do want you to fill out this title block as much as you possibly can. Come up with a number or a thing right here. Make it a title in there. University of Hartford. Put your name and the date in the comments. Maybe that's a good place to put what this thing is and what the pitch is at least. So I'm going to go ahead and do a little bit of sketching on here. Oh, one thing to start out with. Oh, excuse me. I'm going to click on this again, and I'm going to turn this into hidden view, so we can see the other gears in there. We could do a variety of things to mark that up and do it correctly, but I think this gets the job done. I think you should put out call out leaders on maybe both things right there, just to make sure that you've that it shows. Let's see. I'm also going to do, before I do the annotations here, I'm going to go to the center lines, and I'm just going to put them onto here, right there, there, and there. That's good enough right there, center line. You could also put, if you wanted to, put the little centers in here if you want to. So some people like to put the center marks on top of the thing right there. Boom. I don't know if there's anything worth about that, but it kind of shows up. All right, so I'm going to go into the annotations here and do the circle thing. Circle, circle. Oh, and it would have made sense to make that construction while I was there, but I can make them over here. They look better as construction, as you can do them as you're doing them. Construction, construction, and I'll go back and fix the other one here. So go back to this one, make him a construction. And you know the diameters that they're supposed to be. Oh, do this all the time. Escape. Make sure you change into inches. All right, I prefer to do that afterward, before I start making my dimensions. And so this guy is supposed to be 2.666. And, you know, I don't like that kind of dimension, so I'm going to come back here, and I'm going to go like that right there. I like to be able to control my dimension that way. I don't want to do that dimension. I want that kind of, come on, stuck it. And so that dimension is, that's the 96 teeth is 16 inches. No, it's not. Oh, no, yeah, it's not. Duh. It should be, this should be the 28. No, the, what am I looking at? What am I looking for? Oh, 14. It's the 14 inches. Yeah, that makes sense. See, that's the reason why I'm doing this, is to it makes you think about the thing and not just blindly running out numbers. Like, do you really understand what the machine looks like? I think that's rationalizing. All right, so the 96 is the 16. Gives you sort of sense right there. Okay, so that right there, and then this last one. I don't know if we'll be able to fit the diameter in there. Let's see. That's going to be the 4.66666666667. Doesn't matter how many, but all right. So there you go. Let's see. We can also, while we're here, No, nothing like that. Let's do this again. I'll do that. I think it'll do it. The center marks just messed me up. There you go. There's our center mark. And while we're there, you might want to add another decimal place. Boom. No, it's too many. 4 sig figs. Yeah, there you go. You know, for sure. We could also, while we're here, mark out that distance right there, and also that it is 3 sig figs. I guess, I mean, it's redundant, but it does tell a story right there. And then lastly, I think what I want is for you to label these. So I will go to annotations and go to note. And I'm not very good at controlling these. You could go right onto the thing, or you could, I preferred if, I'll show you what I was saying here. Like, okay, so I just forgot which gear this is. That should be gear 4. Gear 4, and label how many teeth there are. The gear 4 has 84 teeth, right? And cool. And now you could do that again, but of course you're not going to label that gear. You could go here. Is gotta be better to put gear 3 over to the side, wouldn't it? Over to the left side, gear 4 onto the right side, but that's not how I did it. 16 teeth. We'll go right here. This should be gear 2. 96 teeth. Alright, and then this guy here. Could label them in here, but I like to have labels on the outside. Gear 5. Is that correct? Yeah, gear 5. And that one is 28 teeth. Hit escape. There you go. You could label them. I mean, having them next door, people can look at this and follow what they are. You've communicated effectively. I will ask you, so 27-minute video so far. I will ask you to, I said I wasn't going to do this, but you should fix this. And just, I mean, you can make it into S. Yeah, I found that you had to get rid of it to be able to edit it effectively. And that'll be homework 10. And my goal here when doing this is to make it look like a number, right? A drawing number. A drawing number is something that the file might also be name this, or you would look this up in a directory. It's like the official thing, and there would be a drawing number standard for whatever company or business or government organization or whatever that you would be in. But here's where you'd give the description of the thing enough that like it's unique. But you know, we have. Why did I make it 2020? Do I think it is 2020? That's the real question. Do I know what year it is? There you go. And yeah, he's hiding in there. University Hartford. And you know, if you do this enough, you should make this like a standard thing for yourself. By the way, we have to make sure we're technically correct, and this is not 1 to 10. It is 1 to 4. And I don't really have it down how to change that automatically. It's not that hard to figure out. And I in love with my own name, so I'll put it in there. You could just put initials in. And today is officially the 11th. 24, and checked by nobody. I said I would put on, you know what, I'm going to cheat and I'm just going to keep using this box. And I'm going to write pitch. Did I say 6? Yeah, 6 teeth per inch. You can put anything you want in the comments, I don't care. But it's identify the thing. You know, you have this like to be determined kind of thing. Finished to be determined. Yeah, sure. To be determined, yeah. You just want to like leave things blank, except for this stuff right here. This might be like, well, this hasn't happened yet. And then, as I have mentioned several times before, I just find the proprietary thing just kind of silly to put on a student thing. And if you want to get rid of this, you trim off that one. I think you have to trim that one and that one. The other ones right there are just deletable. Okay, so it just robs a bunch of space that didn't really need to be robbed. So there you go. And then you can save this. Always a good idea. But homework, I'm going to do my example. I'm trying to be a good example here. And then print to a PDF. And yours might look different. You might have other choices. Boy, do I have a lot. Here's why I have Adobe PDF is one of my choices. In the page setup, you could pull down and find tablet. On my one at home, it's a lot less. Well, it depends on which printer driver for the PDF you're using. But I'm using tabloid. All you gotta do is hit preview. Yes, it looks like I want it to look, and then hit OK. And put it someplace that you can find it. No, that's not it. I want to go SolidWorks. SolidWorks. No, not you. You. And I could have left it as example, can I? But example. Bada bing, bada boom. There is our beautiful. Look how gorgeous it is. Actually, I wish my hidden lines were a little bit better. Yeah, these look pretty solid. I'd rather have those be construction line-y. They only get broken very rarely. Yeah. But yeah. So what is the time? It's like 32, 33 minutes. The assignment won't be that long, but you should be able to do it now. Thank you for your patience, and see you in class.